Next, let's talk about scaling elements. When sizing elements in a layout, we can use fixed sizing using pixels, elastic sizing using ems, or fluid sizing using percents. And we'll also look at using min and max sizing properties. In a fixed layout, you can see that all columns are specified using pixels. So in this case, a 520 pixel column and two 200 pixel columns are separated by 20 pixels of margin, which adds up to 960 pixels total. One of the pros of using a fixed layout is that the elements on the screen that are sized in pixels will be exactly the same size on all screens, large and small. The only downside here is that this could create excessive white space for users that have very large screens. Then the content isn't making use of the full screen space. Another detraction is that on very small screens, if your content is sized larger than the screen itself, it may require horizontal scroll bars, so the user will have to scroll over to see the rest of the content that's getting chopped off. So fixed layouts are not necessarily ideal for responsive designs that are meant to change the content size for different size screens. We can also create elastic layouts where the columns are sized using ems, and these will be in proportion to the text size changing up and down. So the pros are that when we scale up and down the text, we'll be able to keep the containers in proportion to their text content. The only downside to this is that as text gets larger, it may cause their parent containers to start to bump into each other. So this requires a lot of testing and checking out the layout on different size devices and text sizes. We can also make fluid layouts. So here all of the columns are specified using percentages that are based on a percentage of space within the parent container or the percentage within the browser window. So one of the pros of using a fluid layout is that this will make full use of the screen and it will eliminate horizontal scroll bars at smaller screen resolutions. Now the only downside to this is that as designers we have less control over what the user sees with regards to container sizes and where type and media will begin to wrap. We also have the ability to set thresholds using the min and max properties. So you can say min width and max width, and you can also say min height and max height. And what that will do is it will set up a starting and stopping point for when the container will begin to grow and when it will stop growing. So basically, if you had a min width set to 960 pixels, as the screen scales down, the browser is going to allow the element to be fluid until it reaches that 960 pixel amount, and then at that point it's going to stop shrinking and actually become a fixed unit. And this means that it will never get any smaller, the width here will never get any smaller than 960 pixels. Now, if we start opening up the browser wider and wider, the wider our browser becomes, at the point of 1080 pixels, which is the max width, it will actually stop growing and we'll start to see white space will appear. So in between the min and max, this element will behave as though it is a fluid element, but outside of those boundaries, at a maximum of 1080 and a minimum of 960, it will begin to act like an element that has a static or fixed pixel amount. Let's take a look at an example here. I've gone ahead and created a div, and here I've given it a background color of aqua. I've given it some padding, some margin, and set its font size to 1em. And I've also created some classes here that will apply different types of widths. So this one here is called fixed size, which has a width of 200 pixels. And then I have a class called elastic size here where the width is set in ems. I have another one here where the width is set in percents, and another class here that has the min and max width set. So first let's take a look at this element here, and let's go ahead and apply this class of fixed size to it, which will give it a width of 200 pixels. Okay, and you'll notice that as soon as I apply that class, now with a fixed amount of pixels, this will stay the same size on any size screen. And when the screen gets smaller than the element, we need to use the horizontal scroll bar to scroll over and see the rest of the content. Okay, I'm going to go ahead and duplicate this div here. We'll just copy and paste it. And this next one I'm going to give the class of elastic size. Okay. So in order to calculate the exact same size using ems, what I did was I took the 200 pixels, which is the size I wanted it to be, and I divided it by 16 pixels, which represents 1 em, and that came up with 12.5 em. So here, 12.5 em is the equivalent of 200 pixels in this case. And the difference here is that you're going to see that when I scale the text up and down, unlike the pixels, the container is also going to scale proportionally with that text. So here I have the body font size set to 100%, and let's just double this up to 200%. And you'll notice that here inside of the fixed pixel amount that the text has gotten larger, but the element has stayed 200 pixels in size. Now here in the elastic layout, where we specified the width here in ems instead, 12.5 ems, when the text gets larger, the container also gets larger proportionally. Okay, so let's create another div. And this one we're going to set it to fluid size, which will give it a width set in percents. So here we'll write you are fluid, you are sized in percents. Okay. And this one's going to be 70% of the screen. So here when I change the size, it's going to stretch or shrink depending on how much available space there is. Okay. And you can see even when I scale this down very small, we're not going to get horizontal scroll bars in the way that we do for fixed and elastic. We don't need those scroll bars here for fluid because fluid is just snapping to the appropriate size. Lastly, we can make another div here, and we'll give this one the class of threshold size, which will apply a min width of 500 pixels and a max dash width of 900 pixels. So you can see here that when we use min and max, when we make this larger than 900 pixels, it stops growing. And then when we start to make it smaller here, it's becoming fluid, it's shrinking down. And then once we get under 500 pixels, then we're going to need scroll bars to scroll over because it stops shrinking at 500, just in the same way that it will stop growing at the max, which is 900. Much like the width attribute, the height attribute also allows us to set its sizing based on pixels, ems, percents, or min and max values. Here in this case, we've created a div with some place filler text, and you'll notice that it's currently only as tall as the content inside of it, and that's because we haven't specified a height for this element. So in the absence of specifying a height, which is really the same as setting the height to auto, it will only be as tall as the content dictates. So to demonstrate that this is true, if we add more content inside the element, we'll see that it will grow in height. We also have the ability to set a fixed amount of height. So for example, if I set the height here equal to a pixel amount, let's say I say 300 pixels, then you'll see here that regardless of the size of the content, we've now set a fixed size for the height. Now the only drawback of this is that if at some point our content scales larger than the size of our height, for example if I set the height to a smaller amount that is under the height of the content, you'll notice that the content starts to overflow outside of this element.